Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, it's time to make some more progress on our 6LU8, otherwise known as the SPUD 2.0 build or the DIY small amp, whatever you want to call it. I think this thing's going in a really good direction. Really liking the progress that we've made, and it's starting to look really nice. I think I underestimated how much stuff is going to be packed inside this small chassis. So again, if you want to have a little easier job and you don't mind having a little bit bigger chassis, probably would be a lot easier to build with a couple of inches more on each side. But one of my goals with this is try to see how much stuff I can pack into this small of a chassis and how much power we can get out of it. So anyway, time to get busy building this amp. Okay, time to do a little more wiring here. One of the things I did, I showed you where these were going to be connected, but I went ahead and soldered these in place. These are a couple of 100 ohm resistors. These go from each side of the 6.3 volt heater wiring over here to this ground point. And that creates a virtual center tap so that these heater windings aren't just floating in space. They're actually referenced to ground. And that helps them stay quiet. The other thing, let me see. Might be a little harder for me to get this one on camera. Back here behind this tag strip, you'll see this little resistor here. This is a 470K, and we're using a 1 watt. You could use a 2 watt, but it's only pulling about a quarter of a watt of power, so I'm okay with using a 1 watt. This is the bleeder resistor that helps drain these capacitors when the power is turned off. And when you have tubes in place, the tubes drain this power out of these capacitors pretty well, but this gets the last little bit of voltage out of them. And in case you power up the amp without the tubes in place, this resistor will drain these capacitors, because without this bleeder resistor, these things would hold hundreds of volts on them for quite a long period of time. And it still takes a couple of minutes for it to drain them down, but it's definitely safer than not having any bleeder resistor at all. I was a little hesitant to put a lower value than that in this amp because we're already pushing the limitations of this power transformer. And this is pulling, I think it was 0.6 milliamps, so it's not going to have a negative impact on our power supply being able to power up this amp. If I'd put one in there, twice this, and it was pulling 1.6 amps, we're that close to where I think this power transformer can handle, so we don't want to be doing that. Okay, so next we're going to start wiring up the tubes. So let me show you the wiring diagram for the tube we're going to be using. And this is our compactron tube that has 12 pins, and we're not using pin 3, pin 5, and we're not going to use pin 7. You can see these two pins are tied together internally, so you could use either one, but I'm going to use pin 6 so we have a space between these. So 7, 5, 3, we're not using, so we're going to bend those over and cut them off. These two pins are our heaters, 1 and 12. 11 is the cathode of the triode, or the input tube. 10 is the grid of the triode. And you can see the plate comes around here over to pin 2. And the plate for the pentode's over here on pin 4. So both the plates are over on this side of the tube, and the cathodes are all over on this side. You can see pin 9 is the cathode of the pentode, and this is the screen of the pentode, or where we're going to be hooking the ultralinear tap, and then this is the grid of the pentode, pin 6. Okay, these two are the heaters. This is the plate of the triode. This is the plate of the pentode. This is the grid of the pentode, or the output section. This is where the ultralinear is going to be hooked up, or the screen of the pentode. This is the cathode of the pentode. This is the grid of the triode or the input tube. And this is the cathode of the input tube. And this is the other heater. So for now, we're going to wire up the heaters on this tube and this one. And I'll show you how I make up my heater wires. So I use 18 gauge solid core wire. And we get it twisted a little bit like this by hand. Then I come in here and put one end in the chuck. Try to get it as centered as we can. Tighten that up. You're probably going to ruin the insulation on that little bit of wire there. But then we just go like that. And I've learned to just hold this by hand on this end. I used to put it like in a pair of vice grips or in a vise or something. And I found that it was too easy to over twist this wire. And if you're holding it by hand, you can only hold it so hard before it just starts slipping. And this is kind of what you want to see. About a 45-degree angle on the wire. Let me zoom in here and show you what that looks like. So you want it to look about like that, like a 45-degree angle on the wire. So let's go in here and bend these up and start making up our heater wires. You probably want to cut off the end that was in the chuck, like I said, because it usually damages the insulation. And then you want to untwist the wires and get something like that together that's the width of these two terminals. And so we're going to come in here and strip just a little bit off the end of these. Like that. And then I think I'm just going to come in from the top side. So we got plenty of room because this does have this metal ring. And we don't want to end up with a short. So we'll just come in from the top like that. Eyeball where we're going to have this go. And it just takes a little messing with it. And like I've said in many of my other videos, don't get in a hurry. Just enjoy this part of the process. If you don't enjoy like doing things like this probably isn't something, a hobby you should really be getting involved in, because part of the joy of it to me is trying to see how nice you can lay this stuff out and really have it look neat. And it's always better to leave a little extra length because you can always trim off some, but if you cut it even just a couple of millimeters too short, you'll have to start all over. So those two are going to go in there. We're getting really close here. And there we go. We have our heater wires going over to our first tube. Now, the second one, we're going to come down here and across and then over these. And that's going to get kind of pushed down up against the chassis like that. And the second pair will go over the top of these. And we'll probably hold this down like this while we solder these two. Let me go ahead and I'm going to pull that out and bend that just a little bit. Sometimes you just have to kind of play around with it till you get it where it'll like lay down where you want it to. I think this one needs a little twist on the end is what's holding it up. And I'm going to trim just a breath off the end of that one. I don't want it sticking through far enough where it could possibly ground out on that shield. So go ahead and solder in this first connection here. go. I'm going to pull that back and get that right where we want it. There we go. On the second one, we're going to come over, then down, across, and back up. So, like that. For some reason, to me, the heater wiring is one of the cooler looking things inside of an amp when it's done right. And a lot of people don't spend a lot of time doing it, but I think it's really important to do this right, or you end up with hum and noise in the amplifier. And nobody wants that when they're done with a project and having to chase that down. Plus, it's really difficult to come in after the amp's built and try to fix a problem with the heater wiring. It's much better off to do it right while you're building it. And it's why we do the heater wiring first, because the rest of it all goes on top of the heater wiring. And I'm going to leave these a little long to start with. And they're going to sit in there kind of like that. Try to get these bent up where they lay down on top of each other. Now, we could have daisy chained off of these and come over to here, but since this one's such a short run, I'm just going to run 2 pairs of these in parallel with each other like I'm doing here. Just like that. This connection up there is really nice. Now I just need to figure out how I'm going to do this side over here. And I want it to come up right between these tubes. Well, actually, it's okay for it to be a little closer to this one because we've got some signal path over here. So let's just connect it up just like that. And again, don't get in a hurry. Just enjoy trying to make this pretty. Now, some people think this is like super tedious and they don't enjoy it, but I hope y'all have as much fun doing this part of the build as I do. There we go. I think that turned out real nice. So let's come in here and solder this up. There we go. So at this point, we're ready to put the 2 tubes in, and then we can pull this up on a variac. We can ensure that our heaters are working and make sure that we have high voltage DC on this pin right here. And then once we check this out, we can run our other tag strip over here with some capacitors and resistors. Then run the wires over here to the tag strips we're going to put around these tubes, and run the wires to the pins and get this thing done. So I'm looking at how I want to lay out the wiring to these tubes, and going to be putting a 5-terminal strip like here and then over here. And the way I'm planning on laying out the wiring on this strip is we're going to have the grid leak resistor from the pentode go between here and here, and then we're going to connect this pin and this pin to ground, and this is going to have a wire that runs from here over here to our star ground point. So the cathode resistor will then come off of this pin. We'll have a wire that runs up to here, and then the cathode resistor is going to go between this pin, and then the cathode bypass cap can go across here. And this is for the cathode of the pentode on the output. So then this tube here is going to be the grid for the input tube, and then we can hook our signal wire up here, the ground here for the negative return path, which will then again go back to our star ground point. And then I can put our grid stopper on the input triode between here and the grid. And then this is the cathode for the input tube. We can put our LED between here and here. And then we can put the secondary resistor from here over to the ground point. Now, one thing that I'm a little concerned about, this is a little bit higher powered amp than the 6BM8, and this 5-watt resistor is going to be sitting about right here with the wires coming up to this point and this point. What I'm worried about is the heat that's generated from this resistor getting trapped underneath the amplifier. And you probably saw on my EL34 and my 300B that I chassis mounted the cathode resistor on the top side of the amplifier so the heat didn't get trapped underneath here. Well, not going to be doing that with this amp, but I think I need to provide some ventilation here for this resistor to be able to vent the hot air out through the top of the chassis. And so we're going to come in about 20 millimeters from this screw, drill a couple of 1/4-inch holes, and then get my Dremel tool and slot between them and put a little slot here behind each one of these tubes for this resistor to be able to convection cool by the hot air rising up through that slot. And the amp's going to be sitting on little feet with the bottom open so that the air can then come in from the bottom and go out through the top. So this is going to be a little tricky, and so probably going to do this off camera so I don't inadvertently screw up this chassis when we've got this much work in it already. So let me work on creating those ventilation slots in the top plate of the amplifier, and I'll show you what that looks like when I'm finished with it. Okay, I got my ventilation slots done, and I think they turned out nice. I mean, they're not absolutely perfect, but they're definitely good enough. And we got one here, we got one here. I also went ahead and temporarily installed these tag strips just to kind of see where they were going to go. So we got a 5-terminal one here, we got a 3-terminal one here, and then we got another 5-terminal here, the larger style, because we got a bigger bolt hole here. You can't drill these out or grind these out big enough to go over these big bolts that are holding down the transformer. And so the way these slots are going to work is the cathode resistor is going to sit like right there. And obviously then the heat from it can go right out this slot. We're probably going to be doing some of the next steps more of a breadboard fashion because I'm not sure exactly which resistor we're going to use on the cathode, and even if this 120 ohm resistor here is going to be what we end up with, which is good for you guys that I'm doing this because then you don't have to experiment like I am. The other thing I went ahead and dealt with, because not all of you are going to be using this same little LED lighted switch like I am. When I use these switches that have an LED built into them for illumination, I try to wire them up to give the LED the best chance of having a super long life. And I know I've seen where you can like just put a diode in line with them to rectify the current a little bit, but I go ahead and install these little tiny full wave rectifiers and then put a small smoothing cap here so we get some pretty clean filtered DC to run the LED. And then I use somewhere around 3 to 3.3K dropping resistor to dim them down a little bit so they're not super bright. and then wire them up here across the 6.3 volt AC. This is our DC. And then these run over to the switch over here. And then I use a little clear hot glue to kind of hold these things in place down to these heater wires and tag it down here so that, we've got a nice little stable setup here for DC for our little illumination light. And I know that's overkill, but that's how I do it. The next thing we need to deal with is we need to ground these output transformer common or negative leads to our star ground point. And while it's not absolutely necessary to do in an amplifier that's not using global negative feedback, for safety reasons it is important, because if there happens to be a short in the output transformer windings, we don't want hundreds of volts of DC ending up on these speaker terminals. So if these are grounded to the star ground point and the output transformer shorts out internally, it'll blow the fuse. So we're going to run a pair of wires back behind here like this and down, and we're going to connect them to this tag strip on the end here. This is a ground point that's hooked to the chassis, and then pull these up and connect them to these two speaker terminals. So next we need to connect the ground wires to our tag strips, and this terminal here is going to be the ground for the capacitors for the power supply front end. We're going to run a ground from here over to here and solder it with these speaker terminal grounds over here. Then each one of these, the center one, needs to also be brought over to this ground point right here. So I'm going to pull them along this front edge like this and come up over these capacitors and connect to this ground point. So let me get that done and I'll show you what that looks like. Well, as you can see, we're making good progress. Things are going exactly like I hoped they would. I built a few of these SE amps, so I kind of know what to expect, but when you're doing something that's totally new, especially not a proven, like, oh, there's a bunch of people that have built this amp and all that, you never know what you're going to end up with. So again, do not get ahead of me on building this thing. This thing may sound horrible. I don't expect it to. I wouldn't be doing all this work if I didn't expect this thing to turn out really nice, but hey, you never know. So, I'm going to pitch again my little Hakko soldering iron. This thing works really awesome. I also picked up one of these little fans for pulling the fumes off the soldering, and it's one of the reasons that I'm not showing as much soldering in these last couple of videos is I'm not able to run my fan when I'm doing this and talking and recording at the same time, and I don't need to be breathing all these soldering fumes. So you'll have to excuse me on that deal. Be careful though, buying one of these that is not 120 volts. This one was 110 volts, and I was like, wow, this thing makes all kinds of racket. Well, turns out it's 110 volts. It says right on it. And when I put it through my bucking transformer that pulls down to 110 volts, it works like you expect it to. And while it makes some noise, it's not objectionable. So if you're going to get one of these, either make sure that you get a 120 volt model, or that it's, rated for 120 volts, or use it with a bucking transformer. So I'm not going to recommend getting this one. Got this off Amazon. Again, if you don't have a bucking transformer, you don't want this thing. It makes too much noise. But this I highly recommend. Put a link in it below. And anyway, I think that kind of wraps up this round of this amp. We're going to have another episode coming out tomorrow, so stay tuned. And until then, have a nice day.